Today's lesson will be an introduction into rational numbers. We've been working with integers and we're switching over to rational numbers, which is basically fractions. Do you know what happens when you try to divide by 0 in a fraction? You never want to divide by 0. If you try, the whole world will explode! The definition of a rational number is any number that can be written as a fraction. So, for this example, a over b represents a fraction. So here are some examples of some rational numbers. So the first one, 1/2, because obviously that's written as a fraction. This next one, 0.75, this decimal can also be written as a fraction. That's the common decimal to fraction 3/4. So that is also rational. Now, 6, you might be thinking, well, that's an integer. Well, actually, every integer is rational because you can write 6 as a fraction. 6 divided by 1, or 12 divided by 2. And then this last example, here is a repeating decimal, 0.33 repeating, can be written as 1/3. So all of those are examples of rational numbers because they can all be written as a fraction. In this diagram, I am comparing rationals and integers. As you can see, the circle of integers is underneath the circle of rationals. It's within it because every integer is a rational number. But not every rational number is an integer. So as you can see, I've come up with some examples here. We have integers -3, -1, 8, and then 14 over 2, because it equals 7, is an integer. And then on the outside here we have rational numbers that are not integers. So 5/7 would not be an integer, and 0.8 and 0.11 repeating. So those are only rationals that cannot be integers, but every single integer can also be a rational. Fractions can be written in infinite forms. So I'm going to talk about what it means to be an equivalent fraction. All that means, there could be two fractions that look different, but technically they're the exact same fraction. So here I've given a few examples. We have 1/2, 2/4, 3/6, 4/8, 50 over 100. There are an infinite amount of ways to write 1/2. Those are all equivalent fractions. What our goal is to always write our fractions in simplest form. So in this case, all of these fractions, the simplest form would be 1/2. Here we have the fraction 36 over 40, and our goal is to write that fraction in its simplest form. So what you need to do is try to determine, is there a number that you can divide both of those by? That being the same number that you can divide both of those by. Well, I know that you can divide both 36 and 40 by the number 4. So let's see what happens when we divide them both by the number 4. 36 divided by 4 is 9, and 40 divided by 4 is 10. So it is in a simpler form. And you have to keep going until you realize that the two numbers left, there are no common number that you can divide them both by. And in this case, there's no number that you can divide both 9 and 10 by evenly, so 9/10 is our fraction in simplest form. My second example is 54 over 60. Now, we need to figure out what number can we divide both of them by. Sometimes you might not get the biggest number possible on your first try, and that's okay. What I like to do sometimes is if I realize that they're both even numbers, I'm going to start, why not just divide them both by 2 and see where that gets you. Cut them both in half. So 54 divided by 2 is 27, and 60 divided by 2 is 30. So we've reduced it, but it's not in simplest form because now the numbers that are left over, I can divide both of those by 3. 27 divided by 3 is 9, and 30 divided by 3 is 10. Hey, we got 9/10 again. That was just a coincidence. But I want to show you one quick thing. See how we divided by 2 and then divided by 3? If you think about 2 and 3, 2 times 3 is 6. We could have gone back to the beginning and just divided by 6. And it would have gotten you straight to the 9/10. Let's do one more together, and then I'm going to give you 3 for you to try on your own. So 12 over 20. Well, I know they're both even, so I can divide them both by 2, but is there a larger number that we could divide them both by? And the answer is yes. We can divide them both by 4. So 12 divided by 4 is 3, and 20 divided by 4 is 5, and then that's as far as we can go. So it reduces to 3/5. Here are your next 3 examples. I want you to pause the video, try them on your own, and then check your answer. Nice job! We're still working with equivalent fractions, 2 fractions that look a little bit different but actually are the exact same. So for this part, we're going to move from a mixed number and review how to change it to an improper fraction, and then we'll go backwards. Here we have 4 examples of mixed numbers, and we will change them to improper fractions. So to do that, we take the front number, and you multiply to the denominator, and then you add that number to the numerator. So 2 times 2 is 4, plus 1 is 5. That is our new numerator, and then our denominator stays the same. It stays 2. So all you're doing is getting a new numerator, keeping the same denominator. And this is improper because the larger number is on top. Okay, the second one, 7 times 4 is 28. 28 plus 1 is 29. And then you keep the denominator, 29/4. Now this one's a little bit tricky because there's a negative in front. What I want you to do is ignore the negative sign when you convert and just bring it over into your final answer. So 5 times 4 is 20, and 20 plus 3 is 23. So 23 over, keep the same denominator, 4. Negative 23 over 4. And then the very last one, 3 times 6 is 18, and 18 plus 5 is 23. So we have 23 over, keep the denominator, 6. So that was just a real quick example changing mixed numbers to improper fractions. Now we have 4 examples of improper fractions, and we're going to change them to mixed numbers. So let's first look at 27 over 8. Think about how many times does 8 go into 27 evenly? Let's see. 8 times 3 is 24, so 8 goes into 27 3 times evenly. Now think, 8 times 3 is 24. How far away are you from 27? You have 3 left over, so that's how many are left over here, and then the denominator stays the same, 8. 3 and 3/8. Okay, let's look at 43/9. How many times does 9 go into 43 evenly? Well, 9 times 4 is 36, so it goes in there 4 times evenly, and 9 times 4 is 36. So now 36 is how many away from 43? it is 7 away, and then you keep the denominator of 9. 4 and 7 ninths. Okay, let's keep going. 16 over 5. 5 goes into 16 3 times because 5 times 3 is 15. And 15 is 1 away from 16, so 3 and 1, keep the denominator, 5. Alright, the last one. 50 goes into 102 twice because 50 times 2 is 100, which is 2 away from 102, so 2 and 2 50ths. However, this problem is not done yet because 2 over 50 can be simplified. 2 and cut them both in half. 2 and 1 25th. There you go. There's your introduction to rational numbers.